really would rather.
All right, let's graph this hyperbola. Down here it says what our information is. The vertex, we've got a vertex at -2, 4. So -2, 1, 2, 3, 4. There's one of my vertices. A center at -2, 1. So -2, 1. There's a center. So it's going to be opening up and down. And a focus at -2, 6. There's a focus right there. So my graph is going to be opening somehow like this. I'm rough sketching it because I might want to later change around. Here's my center. So if I go this distance right here is my
radius.
What do we call it? The different people call it different things.
What do you
We're
mean?
calling
That's
this the y radius.
Yeah, or y.
And this would be right here. This is your focal radius, R sub f, or some people call it C. Some books call it C. And so I can now find my other, if I go the same distance down from R, which was 3. 1, 2, 3. There's my other.
What's your Rx?
Yeah, there's
or
my.
Not Rx, R.
That's my other. That's my
RY
other vertex. That's my other vertex. All right. So the trick here for a lot of people is to find the equation for the asymptotes. But before we do that, let's go ahead and just write out the equation of this. The equation of the graph. And so I want to take the center, which is right here, -2, 0, and I'm going to put that in x plus 2 squared minus, and so this is actually going to be a positive, and the x is going to be a negative because it opens up. The x is negative, and then it's going to be y. Remember, that's -2, 1, so it's y minus 1 squared equals 1. I'm running out of room, but it equals 1. And so now I have to find out what goes underneath the x term and the y term. A lot of times you'll write it with the positive term first, so let me write it that way. Y plus 1 squared minus y minus 1 squared, thank you. X plus 2 squared equals 1. And now underneath the x is going to be the r sub x squared, which we don't have yet, and the r sub y squared is 3. That's 3 squared, so that's going to be a 9 right there. So how do we find this other one? Well, that's a formula, and it's always a Pythagorean formula. So let's do this work down in this corner in blue. I want you to always remember this distance right here, that's r sub f in this case, is the bigger of the 3 distances, so that's going to be by itself in the Pythagorean formula. So that squared equals the y squared plus the r sub x squared, which means, what's that distance?
25.
25 equals 9 plus r squared, which means r squared equals 16, which means r equals 4, which is nice. So that's just 4 squared, or 16. And there's your equation. But now a lot of times it'll ask you for the equation of the asymptotes. So let's talk about how we do that. I'm going to take my different focal radii, and I'm going to take that center right there, and I'm going to go...
I have a question. I think that's backwards.
You think what's backward?
Shouldn't this be a bigger number than this?
Nope. These two, it doesn't matter. These two numbers, the positive and negative, it doesn't matter which one's positive or negative.
That's not what I'm asking.
In hyperbola. What are you asking?
Shouldn't the bigger number be under the major axis?
Nope. In an ellipse, the bigger number's under the major axis, but not in hyperbola. In hyperbola, it's all about which one's negative and which one's positive. In a hyperbola, your r sub x is always underneath your x, and your r sub y squared is always underneath your y.
I know, but I put it the other way.
So what's your r? What's this distance?
I just messed up. It's fine.
Right.
It's fine.
So this is what we're doing. This right here is 3, and this right here is 4.
Yeah, I got it.
And so 1, 2, 3, 4. That point right there. 2, 3, 4, and that point right there. Those are the 2 points on your asymptote. So there's your asymptote. There are your asymptotes. So I actually should go back and redraw my graph because it's a lot more wide than what I've drawn in here. Now that I've got my asymptote. So really this graph should have looked like that. And that's what the asymptotes help you to find. So again, what's the question? How do we find the equation of the asymptote? Well, what do we have here? We have a point and a slope. The slope is the rise, which is r sub y, over the run, which is r sub x. And our point here is -2, 1. The point slope form of the equation of a line, you remember that? It's y minus y1, which is that x, equals the slope, which is the rise over the run, r sub y over r sub x times x minus x1. And the only difference between these two dotted lines is this one's going to have a negative, one of them's going to have a negative, and one of them's going to have a positive slope. So that's all you have to do to find the equation of a line, right there.